All right, so here we have a Ruby file. It's pretty simple, right? It's just requiring a couple things. REST client, has any of you used this in Mod 1? Yeah, right. It just allows you to utilize Ruby to make network requests. That's all. So the first thing is, oops, I don't need this. The first thing is, it's going to put something. And it's going to be, hey, I'm going to take a quick nap, and I'll be right back. The next thing I want it to do is sleep. Sleep takes a parameter of seconds, so it'll sleep for 5 seconds. It won't do anything. And then it will say, okay, cool, I'm awake now. And now that I'm awake, I'm going to go make this HTTP GET request. And what I'm going to do is I'm going to run the REST client. It's going to run a GET type request to this URL. And I'm going to save that response in this variable. So let's take a look at what this URL will give us. So we have an understanding what that response might be. Nope, nope. Okay. Nope, just kidding, I added the quotes there. So Google tried to search for it. There must be a mistake. You've accidentally given me food that my food eats, right? If you haven't seen the show, it's just a character by the name of Ron Swanson. He is obnoxiously hyper-masculine. He has a lot of like ridiculous funny quotes. So if I refresh this, I will get a random quote from him. Right? And so that's basically what the response is going to be. Are there any questions? Okay, so I'm going to pause real quick. All right, so it's going to store that, and then it's going to say request is complete. So let's actually put a little binding pry here so we can test to see what that is exactly. Can everyone see this? Mo better. All right, the file is called sync.rb. So here, we have a file called sync.rb. I will run ruby sync. And so it should do exactly that. It should put out, take a quick nap, sleep for 5 seconds, and then do the rest. So let's take a look. Take a quick nap, 3, 4, and then it will actually put out the rest. Any questions on that? That should be exactly as intended. So we have something called the Ron Swanson quote response. Does anyone know what this is? What type of object it is? All right, let's just take a look at what that might possibly be. It's a REST client. Wow. Right? So remember the type of objects that you're working with. That's so important. So it almost looks like it's trying to give it to me, but because it is in fact a REST client object, I have to convert it. And what I'm going to do is I'm going to run this, JSON.parse. I'm going to translate whatever this is into JSON. Does anyone remember what JSON is? All right, it's called JavaScript JS object notation. Even though it has JS and JavaScript specifically in it, ironically, it is language agnostic. That means that I keep talking about like key value pairs. So Python has dictionary, Ruby has hashes, JavaScript called them objects. We needed to take any of these key value pairs, whatever the data structure, whatever the object was in any language, if I wanted to send it across the internet, and then you're running Python and I'm running Ruby, we need them to be able to talk. So they're translated into this JSON object so that both of them can understand it. So it's actually language agnostic, even though it specifically says JavaScript in there, ironically. Cool? All right. So if I were to, in fact, do that, JSON.parse, and then I pass in the Ron Swanson quote. Nah, I should not have named it so long. It's ironic. Cool. And then I finally actually get this. And I can really check what it is. And how can I check what type of object it is?
Class.
Wow, very good. As a class, ironically. So it's an array. So I know I can run the typical like each map, filter, search, find, the array enumerables, the array methods on it. So that's very helpful for me. Boop, get out of here. And that's really about it. That's what happened. If I made a REST client response, a REST client.get, I got a REST client, I got a response object back, in which case I had to parse the JSON. So let's take a look at this. Nope, just kidding. We're fine. All right. So here in JavaScript, I've created a pseudo sleep method. There's no such thing as like sleep in JavaScript, so I had to like make my own. All right. Don't worry about necessarily this implementation. It's not perfect, but essentially a while loop is blocking, and I will explain what that means here in a second. And so the while loop is basically going to count till 12 to the 8th power times whatever number I put in. Because my computer is so fast, it needs to be an obnoxious number. So that way when I run something like sleep 10, it kind of runs for like, I don't know, a few seconds. So let's just put like 6. Give or take, right? I mean, it's not perfect. So what I want to do is exactly that. And it should be very similar to the Ruby we just looked at, right? So right now, I'm going to bring in this. I'm going to actually remove the sleep. So if I save, I'm going to see these 2 console logs, and then now this click on this click button, which I'm just going to tell you right now is like the actual correct DOM node, should work. So if I save, I'll see these. If I click, okay, just kidding. Oh no, did I not? No, it's right there. Anyone see it? This stuff. Oh, dang it. Does he want me to do the whole thing? Clowns. Clowns. That's weird. All right. Lols, you clicked me. All right. There we go. Interesting. That works in vanilla JavaScript. Either way. So this works totally fine. So far, so good? All right. Upon refresh, if I drop in the sleep, I want you to listen for how many times I'm clicking and see whether or not something is actually happening. So if I bring in the sleep function, I hit save. Did you see that like pause? It's because the while loop was running and it blocked anything else from happening until it was complete. So if I said that the while loop is blocking, does this make more sense? If I say code is blocking, will that make more sense to you? It means that while this is running, nothing else can happen. So if you remember back in the 90s, who's been on a website where like while it was loading, you couldn't even scroll, right? It was kind of like a like a 1-star user experience, right? It was terrible. And it's because a lot of the JavaScript, the behavior that the code was being run, blocked until that was complete. So like I can open up a new website like Google Maps, and then I can take a look at the network. So here you can see in the network, what I want to see is all the network requests that fire. So every time I click and move, a ton of these network requests fire. Because the page doesn't fully refresh, it's just making more requests on the side and then coming back with that data for me. That's all it's doing, right? Even if I zoom, more requests. And so does the rest of the website work while it's making these requests? So if I zoom out like crazy, can I click bars while it loads? Yes, I can. The click actually worked and it was running a request and did some stuff. So a lot of these things, a lot of these like network requests are not blocking because they wanted to create a better user experience. Does that make sense? In terms of why you would not want to write blocking code. As we know, JavaScript runs top to bottom, left to right. So it sees this function, it reads it, it declares it, it runs this console log, it runs this sleep. That means that JavaScript, as well as Ruby, is a synchronous programming language. JavaScript, however, is a synchronous, non-blocking programming language. And the reason for that is because of the user experience. They want it to be a better user experience. So the idea is that they want to create something where if I'm doing something, I want it to happen in the background so that it doesn't block my user experience. So how does this happen and why does it happen? We've talked about fetch already, right? How do we write fetch? How do we make a network request in JavaScript? Great. I'm going to just going to plow through. I can tell that for whatever reason, you don't want to participate today, and that's okay. So fetch takes in what?
The URL call.
It takes a URL. It needs to know where to go in the same way that REST client needs to know where to go. So let's just pull that real quick. Bloop, bloop, bloop.
How do we talk about that?
Oh,
That would be the reason for the lack.
I see. And that's
The
a
lack of fetch is
and that's a good point. Who here did the discussion question? Okay, what was in the discussion question?
fetch.
Okay, so let's talk about fetch, right? And that's my fault. Fetch is just JavaScript's way of making a network request in the same way that Ruby can pull in a gem like HTTP party, REST client, and there's like one other like really popular one. The point is that it's not necessarily organic to Ruby because you're like asking a gem to like write some code for you. There's a way to do it, which is what those gems are based on. But for JavaScript, there's no way for vanilla JavaScript, the programming language, to make a network request. It is a functionality added to JavaScript by Chrome, the browser, or whatever implementation of the client that you're using. So like Mozilla, so like for Firefox, or like Edge, you know? Edge is fine, I'm just messing around. You don't want to be using like Netscape Navigator anymore though. So let's explore fetch and what it is. If I were to do fetch, right, how do we know what type of request fetch is going to make? Post, put, patch, or delete? Or get? Oof. I don't know why I forgot that one. Embarrassing. We have to tell it. So we just say the method is going to be get, like this. Just kidding. I think it's an object. Yeah, for sure. So that's how we know, right? If we looked at the Ruby code, how does REST client know what type of method to do, right? We tell it. What is the most common network request? Get. Okay. So that being said, oops, this get right here is completely optional. If you're doing it, yeah. If you're doing, here we go, 2 for 2. Damn, embarrassing. If you're doing a GET request, by default, it becomes optional. Obviously, if I want to specify POST, I should do what? Right. And that needs to be there. Otherwise, it would just assume that whatever URL is in here is going to be a GET. Let's actually take a look at what comes back if I were to log this whole thing. All right, let's get rid of this sleep function. We don't need it anymore, right? You understand what sleep is doing and the point I try to make? Cool. It returns a promise. And so promise is a type object, and we can take a look at it. Promise MDN. And we'll give you a lot of information on what this is. So a promise, right, will either resolve or reject. And that would just basically mean that when I make this promise request, either my URL is good and it resolves and something comes back, or I type in like some nonsense and then it's like, hey, I try to go get that item for you, but I couldn't get it and it was rejected, or it was blocked because I didn't have the right authentication. And so it returns a promise. The problem is, these are some really bad jokes. Actually, I have to do this. It's just, Scrimba is not as robust as I want it to be. So let me copy this real quick. Cool. If we take a look at the actual browser, and that's HTML. Great. if I look and see, I'll see this promise. Wow, resolved. Cool. And the value in here is a response object. So I need to actually convert it into JSON in the exact same way that I did with Ruby. I need to take the response object, convert it to JSON so I can actually see what it is that I'm getting. The thing is, promises go on forever, and you should never break a promise chain, right? Those are really bad jokes, but they'll make, oh, thank you. I couldn't tell if you're laughing at me or just pity laughs, but I'll take it. Here's what I mean by a promise will go on forever. A promise is exactly what it sounds like. And that is, here, we can take a look. Oop. I'm just gonna use this. I'm gonna just kill this Grimbo. It's so much better this way. There's not a lot of code here. It's gonna be okay. So, for the fetch, a promise is just telling you, and so aptly named, that hey, I'm gonna go do something, and then I'm gonna come back with that data. So the event loop video comes in handy because the fetch will literally go out and get some data. And the problem that we're running into is while it's making this network request, while it's going to get this data, do we want to prevent the user from doing anything else on the page? No, we don't want it to be blocking. And so in order to prevent it from being blocking, we have to make sure that the function is no longer running. Because if the function is running and JavaScript's running some code, then nothing else can happen, right? We saw that with the sleep function. So let me get into me being a terrible artist. You know who can draw? Alex can draw? I was gonna say Vera. Vera is an artist. Have you seen her Converse?
Just the one.
Custom. Yeah. All right, so this is how your JavaScript code runs. Ready? So this is like your computer science lesson for the day. This is known as a stack. This is a stack, all right? Just be nice, all right? You believed in Santa Claus for a long time. So what happens is the stack is the data structure in which JavaScript will utilize to execute your code. So it will execute line for line, one by one, and it will tell you exactly what it is that your code is currently doing. So here's what I mean by that. If we compare this line of code, these lines of code, to the stack, the first thing that happens is the call stack is empty, all right? JavaScript starts. There is nothing there. There is a global context execution that is created. Who watched that powerful 3.5 video? Oh, thank God. All right. So if I say global context execution, did I lose anybody? No. All right. So it means that JavaScript is starting to execute your code. It will see this, all right? This is in the execution phase, the part 2, the second run-through. Not the first run-through that stores everything in memory, but the second run-through. I see a function declaration, cool. I see a console log. Is console log a function?
Yes.
Is it being invoked right now?
Yes.
Yes. So the first thing that comes in, right, is I have a little function here. I have another console log function. I have another function. I know. Terrible. So it pushes onto the stack. So a call stack only has 2 functions to it, 2 methods. You can push on and you can pop off. It is known as a first in, last out. Here's what I mean by that. It's called a stack, not because it shares similarity to like pancakes or anything, but if I had like a pancake here, pancake 1, pancake 2, pancake 3, and 4 because I'm a glutton. If I wanted to eat pancake number 2, can I reach it directly without removing 4 and 3? No. I would have to pop off 4, pop off 3, and then I can get to 2. Or it could be a savage and just like carve right through the whole thing. But that's not how data structures work, right? That's just the metaphor I want to use for you. So when this first function, right, pushes onto the stack, the console log executes. The console log, this is probably not a great example, but it will execute and complete. How do we know a function is complete, typically? Console log is like a weird example. What keyword am I looking for? Return. If I see return, the function is done, right? In theory, this is a terrible function too because it doesn't return anything, it just does some stuff. But what I can do is I can have a function, right, named like do nothing. Very good. And then I can just declare a bunch of variables, right? Const variable 1 is equal to yeah. And then it can return no. Then I can do more stuff here, right? I can set another var, which I don't know, kind of trash, right? Don't use this anymore. Don't do this. Do this. Don't do this, right? Very good. Will it ever hit line 16? No, because the return breaks off, right? It says that the function is done. So I finished the console log finishes executing. What happens to the console log? It pops off, all right? Then I see this next console log, all right? So I got to let's do my due diligence over here. It popped off. Bloop, 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 bloop. Then I take the next console log and I put it on the stack. It runs. Wow, that sleep function took forever. 1 star. And then it pops off. Oop. And then it pops off. Cool? Same thing for the next function and the next function. The idea here is what happens when it gets to fetch. Let's say I had some more code here, right? Like more code. Let's say I have another function here, and this is the fetch. I know, it's so good. I'm giving Vera a run for her money. If the fetch goes on and it runs and it's on the call stack, will this ever execute? No, it won't. So in your mind, in order to run line 4 here, this is line 4, right? Let's just imagine this was line 1, 2, 3, whatever, right? In order to get to line 4, function 4, line 3, function 3, has to do what?
Finish.
Has to finish. As we know when it comes to network requests, who has seen me stuck in Rails when I run the Rails server and then I'm just like, cool, we're just waiting on Rails, no big deal. And it does like the starting get to / awesome and we're just waiting, right? That was embarrassing. But it also symbolizes that network requests can take a random amount of time based on your computer speed, right? How much data is being sent back and your internet speed. And so because we don't know how long this fetch will take, we cannot predictably rely on when line 4 will run. Therefore, a sneaky way to make sure that fetch is always consistent in terms of how fast it runs is by simply the second fetch goes on the call stack, JavaScript will see this fetch, it will run the function, and then it will immediately return a promise. And because it returned a promise, what happens to the fetch? It is technically complete. And therefore, this line is done. This pops off the call stack. And now I can run and execute line 4, no problem. Because it immediately returns a promise that the next line of code is not being blocked. Who feels comfortable about why a fetch returns a promise and the implications that it has in regards to the user experience? Great, that's what's happening. The problem is this: where did it go? So this is where it goes. We watched a video of a much better looking man talk about something called the event loop. This is your vanilla JavaScript running your code. This is Chrome, has a special little pocket on the side. Your browser will do this. And this right here, the fetch, even though it returned a promise for JavaScript, so JavaScript can continue running code, and it being non-blocking, will enter the event loop. And when it's in the event loop, while JavaScript is running lines 4, 5, 6, 67, all the way to 1,000, the event loop is now making this network request. It is actually doing the get that you told it. so that it happens concurrently. Your JavaScript is running and the network request is still being resolved at the same time. That is why the user experience is so good. That is asynchronous. Two things are happening at the same time. So fetch is an asynchronous function. Who feels comfortable, I'll guess that question. Who feels comfortable about what I mean or when it is said that fetch is asynchronous or asynchronous code? Cool, thank you. Therefore, what's your question? Sorry. I was
You
gonna
said that Chrome takes that responsibility. Is it only Chrome or any other browser has its own?
Every browser will implement this their way.
So basically they're taking this and creating another thread. So they take its own
Yes.
responsibility to do that job.
Yes.
Because JavaScript is still single threaded, so it runs your.
Correct. So the question is, and I wanted to point this out, this is important, JavaScript is a single-threaded, synchronous, non-blocking programming language. That is like the next step for JavaScript. So what that means is because it's single-threaded, it can only do one thing at a time. In order for it to do two things at a time, it will outsource it. So Chrome, the browser, will use your computer's resources to work on another thread to execute something at the same time. Here's the tricky part, yeah.
There's two stacks, basically.
Not exactly, but you can think of it that way.
Okay.
Because the event loop is not a stack.
Right, because it goes into the task queue and then puts it back on your stack.
Yes, it is known as a queue. Right? This is not another stack, it is known as a queue. And the main difference is that stack is first in, last out, and a queue is first in, first out. So that means that if this network request goes in, and then I make a second fetch request number 2 is on line, for fun's sake, 5. All right? It pops into the call stack and then returns and immediately breaks off the call stack and then enters into the queue. So now there's two things in here. First in, first out. I can predictably rely and say which one should come out first. Kind of. And here's where it gets really dicey, and this is exactly where I want to stop getting too advanced and go right back into the lesson. We've talked about the fact that network requests complete at random times. Who is to say that request 1 is shorter than request 2? Nobody, right? In theory, request 1 could be like, yo, get me every image that existed on the face of the earth. And request 2 is, I want to know a Ron Swanson quote. I could probably say which one's going to come back faster, right? That being said, now I need another place to hold it. So it will fall into something else. And that is going to be, sorry, this right here is not a queue. It is a different data structure. Again, I don't want to get too advanced. This right here, sorry, is the queue. This is the event queue. As these finish, in any order that they want to finish in, it will go into the event queue. So this is network requests, network requests, network requests, once it is resolved. For right now, we will be doing essentially one request at a time. As you get into possibly your project in Mod 3, a little bit more advanced React, and very likely in Mod 5, you will run simultaneous multiple requests. Sometimes a request will make a request. All right? But here we're going to keep it nice and simple. I say that, and I looked at my drawing again.
So the promise goes into the secondary data structure, but does JavaScript still keep track of that promise?
It does not. JavaScript loses track of it once it leaves the stack. So Chrome will put it in a separate holding place, resolve all the network requests. As they are resolved, they will enter the queue. And this is a queue. This is a queue as a data structure, first in, first out. This is not. This is my fault.
So then what would the correct term be for that secondary data structure?
Um,
If there's.
I would say it's.
It's cute as well.
I don't think it's a queue because it can pop off at any time whenever they're done. I would say I don't know the exact data structure that they're using. It is a custom data structure. So that being said,
Why they call it a web? They call it a web API.
correct. This is the web API, meaning the browser is handling this as an API. So the fetch is outsourcing the network request to Chrome. All right.
Any and all fetch requests and network requests will pop out of the stack, so to speak, and move forward to
The event loop.
yes.
The event loop is a custom data structure, I think, that each browser implements in their own way.
So, but it's only for fetch or like network requests.
It's for network requests. Yeah. And then it will go into the queue. The queue here will wait. The queue is, the best way I can think about it is it sounds English. And this is a very crappy way to remember it, but it sounds English, and I just think English people are very polite. And because they're so polite, they will wait until the call stack is completely clear. There's nothing else running here. I probably shouldn't have used this. They'll wait until this whole thing is clear. What I mean by that is it will go, great, fetch. It pops into the loop, goes into this queue, and then it waits. And it checks to see, is the call stack clear? So you'll just run all through all this code over here, blah, 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 blah. And once that's done, there's nothing left in the call stack. It is clear. Then it will go, all right, cool. And then it will pop onto the call stack. So after all your JavaScript is done, that network request pops back onto the call stack. And then you have to do something. You had a question?
Was there a fetch running of your web page?
Say again?
Was there ever a fetch like running of your web page and like have things appear out of order than you intended, or?
Yes, but we're not going to get to that advanced level of networking in this lecture. But yes.
It's a heap. That's true.
A heap, that's what, okay, thank you. So this is a heap. We're not gonna get into that. We're already behind because of your questions, which I highly encourage, but I'm not going to jump into ones that are too advanced now. So that's how I'm gonna keep us on track. So please, more questions if you have them. So this right here goes right back onto the call stack. That would mean that the fetch, the data, as it relates to your code, can you predictably rely on, based on where it is written, what line it's on, when the code will execute for your fetch? Obviously, you make a network request, you get data, then you want to do something. According to what I just explained to you, and in conjunction with the event loop and how JavaScript runs, if fetch is on line 32, and then I have a function here, fun function, right? And I wanted to do something with the data. What runs first? What happens in the then, or what happens in the function, this fun function, if it's being invoked? I don't know. Right. This fun function gets invoked. So, like I said, fetch will do something in the background. We have to wait until it's done, and then something happens. So there's a method on promises called then. And it's on a promise because what does fetch return? A promise object, right? And is fetch being invoked?
Yes.
Yes. Fetch is being invoked right here. Returns a promise. And so this dot then is actually on a promise.
That's why JavaScript doesn't need to keep track of it, because you give it instructions what to do after.
Correct. So you will tell JavaScript, hey, whenever that comes back, the second it comes back, run this dot then function on it.
Does it need to be in a block to know that the then is applying to the fetch itself, or let's just...
Yeah, it's like method chaining. I'm literally running dot then on a promise object. So that being said, JavaScript is powerful. It is line and spacing material. If I put it on the next line, it knows that it's attached on it. I'm putting it here because it's just easier to read. So what comes back from the dot then? What does a promise return? A response object. So there's some sort of response object here. Cool? The truth is, dot then, something came back, and you need to tell it something to do with that? How do you tell JavaScript to do something? You need to tell it, you need to write a function. So then naturally we'll receive a callback function. So, little function here. And like I said, the then receives the response object. Right? The then gets the response object, but you need to tell it what to do, so there's a callback function in here.
The response object is a promise object.
We'll get to that. So what I can do is I can console log, right? For sure after fetch. 100%, right? No questions asked. You have a log here and a log here. This log on 38 is absolutely written after the fetch here, based on this very easy to understand diagram. What can we say and assume the order of the console logs? Will I see this, this, then this? Okay, what order should I see them in? I should see, wow, that took forever. And then for sure after the fetch, and then this object. Because remember, the then here is only after the call stack is clear. Okay? Oh, I didn't save it. That was embarrassing. And there it is. For sure after the fetch. And then, as promised, signed, sealed, delivered, the response object comes back. Cool? Cool. So we see it's not actually the data that we want. It's a response object. And going back all 35 minutes ago of this lecture, I need to do something with that response object in order to make it readable and understandable. And so I'm going to run something like json.parse. Oh, sorry. I think I can run, yeah, invoke a function JSON. So now I can console log it. And what do I get? Does anyone know? Whoa. Promise. So a promise in the then, when parsed, will give you back a promise. So a promise goes forever. A promise will return some sort of object that holds a promise. And so promises go forever, right? That's like the crappy joke from earlier.
But it's not doing another fetch, which is a different promise. It's just
It returns a promise object. In the same way that 9 times 10 returns a number, and 2 plus 2 returns a number. So it's just a number object. This is a promise object. So the dot then will also return a promise. So fetch returns a promise, and then when you then it returns a promise. Cool? So here, the thing is we actually need to do something with this, right? It's resolved. There's some array inside there, and inside there, there's data, the promise value. In order to retrieve the value of a promise, I must then ask it for something. And then, as we know, takes a callback function. Function is also correct, but more specifically, I was looking for callback. So you're all correct. And what is in here? It's the parsed JSON now. Cool. Remember, I can name it anything I want. That's just a parameter for me to explain what's happening here. So how do we make network requests? We run fetch, then, all right, what do we do after the network, I guess, request is complete. We must then do something. And then right now, it's actually a unusable, terrible, dirty, nasty response object that I need to, unusable object need to parse into JSON. Something that I can understand in my particular language. And so I'm just going to do this. In order to feed the next then, in order to get the next then, I have to return this. So that way the next then actually is the return of the previous then.
So then it's kind of like just a callback, like returning the
Then is a method on a promise that takes a callback.
but it works like a callback in a way that or return.
It will be invoked later, yeah. So this is going to be the parsed JSON. Heck, if I returned hot dog, right, guess what I'm getting in here? The string hot dog, right? So, cool. So this is the parsed JSON, right? Now let's take a look at that. Cool. Wow, there it is, the array that I'm actually looking for. So to summarize, how do we make network requests? You run a fetch. Fetch returns a,
Promise.
but why does it return a promise immediately?
So we can pop it off the stack.
It pops off the stack and creates what for the user? Better user experience because the code is no longer,
Locking the stack.
there we go. Now you're getting it.
Stack
Nice. Yeah, I like to dance, I just can't very well. So this is me. Awesome. So what do we do after the response is complete? We invoke a then method on the promise, and that takes a callback because we have to tell it what to do once it comes back. The response object needs to be parsed into JSON so that we can actually use it now. Now that we have this data, right, we can probably finally create. We can make an element like a p tag, and then we can say const p equals to this p dot inner text is equal to
Parse JSON.
sure.
Parse JSON.
Yeah, right. It's the first. Well, that was bad. The first item in the array, all right? So it depends on the type of object that you get back. So your JSON can come in an array of 1, or it could come in like, I don't know, what is it, Reddit? It can come in like this. You probably don't want to be using array of 1 on this because you get back a large nested object. Now that you're in Mod 3, I highly recommend you get something called JSON Formatter as a Chrome extension. If you do not, then your code looks like this. Okay, yes. Yeah, please cop that free Chrome extension. If your code looks like this and you say, hey, Evans, it doesn't work, I can't debug it, I will say, I can't debug it either. Indentation is important. So again, here. Here, it's an object that comes back. And so in that object, I will use object methods. Right? I would say the parse JSON at a key of data, and then data at a key of children for each. One more time. When I get back the data from here, if I were to make a fetch to this URL, I would say parsed JSON at a key of data. This is an object. At a key of children. So it looked a lot like this, right? Parsed JSON at a key of data, right? I don't think, yeah. At a key of data. Or in JavaScript, at a key of data. At a key of children. And because children is an array, I would then for each. This is how I'd start to manipulate the data that I get back per request. Now I want to break down front end and back end. Tomorrow we will use Rails to finally build this back end, this API, and create data like this. So we'll use JavaScript front end, literally running a fetch on a Rails S server that we can control and manipulate this data. And based on the shape of the data that you make, and what I mean by shape is, this is an object that returns a bunch of keys, that also has nested objects, that has nested arrays. You control the shape. So once you have that, then you will tell the front end how to manipulate the data. So the front end is going to be, great, I need data, and I want a pen child here, I want a pen child there, I want to CSS this. Cool, I'll make it sexy. Back end is, okay, what data do you need? All right, let me shape it for you. Let me make sure it comes in an object, in a nested object, in a nested array. so that you know how to deal with it. So everyone's starting to see that divide here, because when we were in Mod 2, it was full stack. It's kind of hard to see where Rails is front end and where Rails is back end. Kind of hard. So now we're starting to see a divide, and it will come all together tomorrow. But this should be like the first inkling of it. So now that we have that, right, and we have this parse JSON, what can we do? Yeah, let's get dirty and just put the document.body and append this p child. Oh, gross, don't do this. Oh, you're right, I totally need to append child. Wow. Boom, there it is.
You want to zoom in on that so the picture?
Absolutely not, no. Some of them are really funny and therefore not always like super cool, you know. But it's on the recording. If you want to like freeze frame them, they're probably okay. All right. Actually, I didn't even read this. Yeah, this one's fine. So the idea here is that you have this data here. The problem is, let's talk about scope. Do I have access to the p tag here?
No.
Ooh, sketchy. All right. So what we can do is we can go. You can create this element, right? If I really wanted access to the parse JSON, I can say let. Why would I use let, not const? I'm probably going to reassign it, right? Let, all right, some response thingy, bob, all right, equal to empty string. And then, because of, oh wow, okay, great, thank you. It doesn't matter, this doesn't matter, right? It does, but for our purposes here, it doesn't. So then I can do anywhere in here where I actually have it, based on scope, which will look outside, right? Some response thingamabob equals to parse JSON. Remember, so something about, I changed it from a string to a array. Don't forget the data types you're working with. Sneaky. All right, and again, the layers of complexity start to get really intricate here. Here's the next thing. Based on what we know about fetch and then, if I console log it, what would I get on 48? Empty string. Absolutely. So why would I even do something like this? Why would this be useful to me?
If you wanted to call it an inner function, then by that time it would
Great. Remember the call stack. Remember the call stack. That was smart. Remember the call stack. Empty string. The fetch runs. At the end of the call stack, it will be assigned. But currently, still, empty string. What if I had something like a form, and I was listening for the submit, and then the function took an event, oops, function only, and then I needed to do something with some response thingamabob. What is this? After the page loads, the call stack is clear, the user sees the web page, and then clicks submit on a form. What is some thingamabob? Is it still empty string?
No.
That's why it might be useful. Because you have to understand the timing of things. And asynchronous becomes very difficult to manage, but I believe in you. Are there any questions on fetch and what it returns? What does it return? Why does it return a promise? To keep the call stack clear for non-blocking asynchronous JavaScript for that 5-star user experience. Right? We cannot do const this thingy to fetch. What is this thingy? It's a promise. Right? So we have to be inside the fetch before we get that data. And right when we leave it, because of scope, it's gone. The only way to try to attempt to persist any of this data is to keep a variable and then assign it at that time, but still be cognizant of where you write your code, because on 48, empty string, but on 52, array. Who feels comfortable about why 48 is an empty string and 52 is an array? Who feels comfortable about that? Awesome. Let's just go through the README to make sure I covered everything. So I'm kind of, okay. Ironically, this is the joke. Not funny, so cool. So these are my objectives for you. I want you to distinguish between synchronous and asynchronous code, right? Recognizes when a code uses promises, so like what is a promise, kind of that deal, and a promise goes on forever. How to use the .then, the method, the handler, how to resolve a promise, basically getting the data inside the callback, and then using fetch, right? So to configure HTTP requests. We talked about fetch in terms of the get, and then we will also talk about the post method tomorrow when we do the Rails API. Cool? All right, remember, JavaScript is synchronous, and it executes one at a time. Network requests take a sketch amount of time, which is why we let Chrome handle it inside the event loop, and then it patiently waits inside the queue for the call stack to be clear. What's your question?
I just want to kind of be clear about when I'm looking at the documentation for promises. Fetch is a reserved keyword for promise.
Fetch is a method that Chrome or any modern browser will give you.
And promise is actually a class, and you can actually make whatever kind of promise you want, even outside of just request.
Yes, promise is not necessarily a class, but it is its own type of object. You can, in fact, make new promises on your own. I actually have, I'm like diving really deep into promises. I'm going to make a new pull request to like ES9 to try to add some cool features. So, yeah, open source, baby. Yeah. Who knows? That pull request can get shut down real quick. So it just costs me nothing to do it. All right, the one thing I did want to talk about is, what if your promise goes bad? What happens if it doesn't resolve? Does any of this run? No, it doesn't. It only runs if it's successful. So there's something in Ruby called begin and rescue, which is hilarious. Ready? Hot dog. Have I ever defined hot dog? No. So what kind of error should I get? Like undefined variable or name hot dog, right? So rescue, right? There's like some name error. It's gonna put hot lol saved you. So let's get rid of sleep real quick. So the idea here in this is that if I were to run Ruby sync, oh I do. I'll just continue it. Okay, I can't do that with binding. Forgot how lame that was. Do you guys like the buy bug? It's powerful. So look, there it is, saved you. Right? If I don't have this in here and I just put hot dog, yeah, it breaks. So undefined local variable or method hot dog. So begin rescue in Ruby is very much like, hey, why don't you try doing something? If you get some sort of error, do something else. Cool? So the rescue is, if this breaks, do this instead, so that your code doesn't break. So in your fetch, instead of the thens, you can always attach at the end something called catch. Cool? And if you ever want to know how to look it up, how do we look up documentation on fetch? Oops, I'm writing into that. Absolutely. Bloop. I look at it a lot. And then there's something called catch in here. Catch is, well, really, oh, I think it's using fetch. What is it? Is it, yeah, using fetch, thank you. In here, catch. Catch takes a callback. So you can have a function, and that's going to receive like bad news bears over here. and then you could console log it, which is great for a developer. But sometimes if this fetch doesn't work and I'm creating this element and I'm putting it in here, I can probably do something like this. And instead of the parse JSON, I can say the inner text is, network failed. Sorry, it's frowny face, and then I can append it. Does that make sense? That way, like, hey, if I make the network request and it works, show me the thing. If it doesn't, hey, add on to the page like, yo, my bad, dog, right? So I want you to get into the idea that like just console logging the error is not necessarily like enough for good error handling. And this is like a really good practice. So catch comes from the idea of JavaScript. There's like a try catch block. And so try catch MDN. W3 Schools is great for CSS and HTML, but it is like a definite secondary resource to MDN. So try, and then you can have a non-existent function. So very much like begin rescue for Ruby. Catch, and it receives something that didn't work, why it didn't work. And all the documentation will just say console log, which is fine because you can actually see what the error is. But again, try to actually do something in case it fails. Cool? All right, so.
So two questions. First one, I guess if we use a catch, do we want choosing const to do that for our variable p?
Should we what?
Should we change from const to that? Because if we keep fetching it, would that overwrite it?
Well, think about this scope, right? Every time I run it and it runs this new function, technically it's a separate function that runs and it will create its own new const.
But at the same time, it can look up the chain and see that they're the exact same thing.
This catch cannot look within these. In the same way, because remember, this catch is a method and this then is a method. In the same way, if I had a function, right, like funny1, boop, 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 and I just declared, right, bankruptcy. I'm just not gonna spell that. I'm very tired. Like, it's like not funny. Right? Do you guys remember that? Bar, right? Scopy. Can I look for declared here?
No.
All right. So the way scope, I spelled bankruptcy wrong. All right. Just. All right.
Well, how does the fetch know when you're done?
That looks wrong. But it doesn't matter. What?
How does the fetch know? Because you said we leave the fetch eventually. And is it just when it's not like one of the keywords like dot net, dot catch, dot finally?
So what is the promise? It's okay. I'll look it up
There's
again.
not like a block that the fetch is actually in. You're just kind of tacking on all these.
Yeah, I agree. So promise, remember, it can either resolve or reject. If it resolves successfully, it will run this. If it fails, it will run this. So it does. These don't ever interact with each other. Yeah. Cool. And this catch is running like like sort of like a catch-all. I mean, you can run another catch here if you wanted to, but I knew that this would probably be fine.
So you can kind of layer like this part fails.
Yeah. Catch individually. Yeah. Powerful.
And the second question is, so as we write more code, we're probably doing a lot of asynchronous action as well. So
Yeah.
there's sort of a program that helps you keep track of what line code is running.
Right. This is talking about like if I have a lot happening.
Yeah.
Promise chaining. Yeah, I know. Again, that gets very difficult. I'm not going to dive into it. We could talk all outside of lecture on it. I just wanted you to understand. This is what I need you to get away from this lecture. All right. So I need you to do me a favor. Just keep your hands up, thumbs up. All right. As I go through things, if you do not understand, put them down. It's easier for me to see like a change like this and for you to just maintain because you have to actively do it. Okay. Making a network request in JavaScript. What does fetch return? Cool. Using the .then. If I say a promise goes on forever, okay, how do I store or save data from a fetch request? All right, outside and then set it inside somewhere. When will I have access to that data? Immediately afterwards?
No.
Or possibly maybe after the DOM loads and the user does something, the call stack has been cleared? Okay, cool, that's it. That's all I have for you today.